In Module 3, we covered how to manage vulnerabilities. In Module 4, Unit 1, we'll outline what those vulnerabilities are and how they affect their targets. Our exam domain objectives cover question 2.3. Let's kick the session off by a compare and contrast of the common vulnerabilities found in your host, network, and virtual infrastructures. As part of your host infrastructure, servers are where we keep much of the critical and highly confidential information and access permissions. Since they also happen to be a portal to that same sensitive information, they are a prime target for hackers. Most operating systems and applications installed on servers support vulnerability. If an organization ensures everything receives regular updates and security patches are kept current, it can reduce the risk of external threats. Something as simple as a non-updated patch can leave a system open to a catastrophic attack, such as the massive Experian breach. Even the largest companies are at risk from the simplest vulnerabilities. Typically, threats to local servers are more likely to come from within. This is why companies have to have good security controls in place to prevent an administrator from turning into an attacker. Dr. Jekyll and Mr. Hyde scenario. Yikes. Endpoints, including mobile devices, are more exposed to attacks than servers. Attackers target these devices to gain access to important data, the network, or both. Because endpoints are more vulnerable, the implementation of real-time monitoring is necessary. Some endpoints have robust security controls readily available, while others are limited but improving. This includes desktops, laptops, and mobile devices. Supervisory control and data acquisition systems, or SCADA, are normally deployed in manufacturing, energy, and other industries for the purpose of infrastructure and process management. Installed on regular computers, these systems enable data collection and industrial device and equipment control. Systems embedded in industrial equipment are known as field devices. Initially, SCADA systems were developed with scant attention paid to security. However, stakeholders are realizing the need to protect these devices since SCADA devices sometimes operate on information system networks. For example, the Stuxnet worm was developed to exploit SCADA software embedded in Windows PCs in order to disrupt the operation of some aspects of the Iranian nuclear fuels project. Hence, implementing security controls on SCADA devices has become imperative. When it comes to the network infrastructure, attackers target network appliances to survey the network, initiate an attack intended to spread over the network, and to launch denial of service attacks. UTM, or Unified Threat Management appliances, firewalls, routers, and switches can have similar vulnerabilities as servers. Monitor access by administrators and ensure your network appliances come with support packages. Keep security patches updated. I'm going to sound like a broken record on that. Equifax. Appliances also run the risk of being compromised through web administrative interfaces. Protecting against vulnerabilities such as cross-site scripting and cross-site request forgery is essential. Keep in mind, the more host devices with access to administrative interfaces, the wider your threat surface. Make sure you vet access requests. Too many laptops with administrative access rights pose a security risk. To protect the network from hackers, implement both physical and logical controls. From a physical infrastructure standpoint, an attacker can eavesdrop or listen in on an exchange, manually copy or transfer data exfiltration, or mount a man-in-the-middle attack if he gains access to physical infrastructure. Attackers who gain access to the physical network can attach an appliance devised to provide a wireless link to a segment of the network, then use the appliance to gain access to other parts of the network. Attacks of this nature can be thwarted by implementing physical controls such as doors with robust locking mechanism, security guards, and periodic security checks. When multiple networks are interconnected to each other via the internet or private routed topology, hackers have the opportunity to hop from one network to another. You can preempt this by permitting movement between endpoints for authorized users only. Employees typically connect remotely via the internet. If a hacker manages to exploit a remote access point, he can penetrate the VPN server. I cannot stress this enough. Ensure a host connectivity to the network only if their laptops or other devices meet security requirements. When using a VPN, use an internet service provider, a public-based TCP/IP address, and a tunneling protocol, which is a secure tunnel for data packets to travel in as they move across a public network. Vulnerability management for virtual infrastructure is similar to the vulnerability management required for physical host systems and networks. The difference lies in the fact that the administration of virtual infrastructure occurs at the hypervisor level and the virtual machine level. Virtual hosts create and manage virtual machines. Proper security controls need to be implemented when creating VMs. Remember, virtual networks not only connect VMs to each other, but also to the physical infrastructure. Incorrect configurations can expose data and systems to risk. Ensure hosts with internet access are located in the demilitarized zone, so critical systems and data are not exposed to the internet. Just a quick nod to your management interface. As a word of advice, separate duties, so a different team supervises the hypervisor. System updates often necessitate a reboot, even if this disturbs operations. Vulnerability management for virtual infrastructure in a public cloud is normally the service provider's responsibility. This can result in security issues. Agreements with the cloud service provider should be carefully scrutinized. Clarification regarding the service provider's responsibility regarding the management of threats and vulnerabilities is important. In such agreements, include a clause requiring the vendor to conduct regular security audits and report the results to your organization. Regular audits and reporting can prevent VM sprawl or dormant VMs.